Okay, students, welcome to the session. So, we were doing some word problems in the last lecture. We have solved the problem and also know the method or the approach how a word problem can also be solved by using the method of Cramer's rule, right? Now, let us consider the same kind of problem in this lecture. What this problem actually says, a total of 8500 rupees was invested in three interest earning accounts. The interest rates were 2%, 3% and 6%. If the total simple interest for 1 year was rupees 380 and the amount invested at 6% was equal to the sum of the amounts in the other two accounts, then how much was invested in each account, right? So, what is the objective of the question? A total amount of rupees 8500 was invested in three different accounts which are running at the rate of 2% interest, 3% interest and 6% interest, right? And the total simple interest for 1 year is rupees 380 and the amount invested at 6% was equal to the sum of the amounts in the other two accounts. This is the condition which is given in the question. The amount invested in an account which is running at 6% interest rate is exactly equals to the amount invested in the remaining two accounts. Then how much was invested in each account, right? So what we want to calculate, we want to calculate how much amount out of 8500 was invested in all these three accounts which are running at 2%, 3% and 6% simple interest. So naturally what we want to calculate, we want to calculate the amount invested in all the three accounts, 2%, 3% and 6%. So what we assume, the case 1 is 2% account, 3% account and the third is 6% account. They are the three accounts, right? And the total amount of 8500 was invested in these three accounts. Let us take the amount invested in an account which is running at 2% interest rate is equals to x, right? Likewise, the amount invested in an account which is running at 3% interest rate is y and the amount invested in an account which is running at 6% interest rate is z, right? X is the amount invested in an account which is running at 2%, Y is an amount invested in an account which is running at 3% interest rate and Z is an amount invested in the account which is running at 6% interest, right? So what is given, the total sum is 8500 means x plus y plus z, this is equals to 8500. This is our equation number 1 because the total amount is 8500, it is being invested in between these three accounts, right? So the total sum of x plus y plus z must be equals to 8500. What is the next? The interest rate were 2%, 3% and 6% in the total simple, if the total simple interest for 1 year is 380 rupees. Now if you recall the formula of simple interest is what? PRT divided by 100, right? Simple interest is what? Simple interest is rupees 380. P is what? Principal. For the first account, the principal is X, right? For the first account, the principal is X. And for the second account, the principal is Y. For the third account, the principal is Z, right? So P is X, R means 2, 2%, time is 1 divided by 100. right? So what we will get, this is equals to 2x divided by 100. The simple interest for the first account will be 2x divided by 100. Oh, this is 3x, sorry, take it 2. This is 2x, right? Not 3x. Likewise, for the second account, 3x. We will get here 3x divided by 100, and for the third account, we will get 6x divided by 100. So this is 3x. This is equals to what? This is equals to 380, right? Means where we should write 2x divided by 100 plus 3%, 3x divided by 100 plus 6x divided by 100. This is equals to 380. Now simplify it, take the LCM from the left hand side, but you will get this will be equals to twice of x plus 3x plus y. Oh, this is y, this is z, because x, y and z, right? So 2x plus 3y plus 6z, this is equals to 380 into 100 means 380 and 2 zeros more, 38,000. Right? This is equation number 1, this is equation number 2, right? Twice x plus 3y plus 6z is equals to 38000. Naturally, PSI is equals to PRT divided by 100. For the first account, simple interest is 380. P is what? X. R is 2%, T is 1. So upon 100. What you will get? It is equals to 2x upon 100. For the second, SI is equals to PRT divided by 100, right? So this is again 380, this is equals to P, now Y. R is 3 and T is 1 divided by 100. So what we will get here? This is 3Y. Like for the third, 6Z, right? So twice x upon 100 plus 3y upon 100 plus 6z upon 100, we will get here as 380. Now simplify it, you will get 3800. Third condition is what? The amount invested at 6% was equals to the sum of the amounts in the remaining two accounts. So the amount invested at 6% is Z. This is equals to the remaining two means x plus y. So this can be written as x plus y minus z. So this is your third equation, right? So this is how we can formulate or we can transfer the given problem into a word problem. Now once the problem has been converted to the mathematical equations, then we can easily find out its solution. So what we are having now, we are having three equations, right? Equation number 1, this x plus y plus z is equals to 8500. Equation number 2, twice x plus 3y plus 6z is equals to 38000. And equation number 3 is x plus y minus z is equals to 0. These are the three equations, and now we can find out the solution of these three equations by as usual method, that is known as the Cramer's rule. So the above system of equation can be written as ax is equals to b, right? Here what is a? A, you know, A is the matrix of the coefficients of the variables x, y, z. Capital X is the three variables under consideration, that is x, y, z. And B is equals to the constant terms at the right hand side, that is 8500, 38000, and the third is 0, right? Matrix, how we write? I have explained it many times. The first row of A is the coefficient of x, y, z in the first equation. Coefficient of x, y, z here in the first equation is 1, 1, 1. So we are getting 1, 1, 1. In equation 2, 2, 3, 6. So 2, 3, 6. In equation 3, 1, 1, minus 1. So 1, 1, minus 1. Now start the process of finding out its solution. So the determinant of A, that is D, is coming out to be minus 2, right? So this is not equals to 0. And naturally, when a system AX is equals to B, if its determinant is not equals to 0, then it directly implies that the system is having a unique solution, right? Now what is our next step? In the next step, we are having D is with us. We will find out dx, dy and dz. So use the same approach as we have already used in the last example, right, to write down dx, dy and dz. And let me explain once more. Dx is simply written as replacing the first column of the determinant D by the matrix B, that is 8500, 38000 and 0. To find out dy, replace the second column of the determinant D by the matrix B. And to find out the third column, replace the third column of the determinant D by the matrix B. So using this approach, we can determine dx, dy and dz. And look at here, this is your dx. The first column is being replaced by B, that is 8500, 38300. The remaining two columns will remain as it is, and when you will simplify it, you are getting its value as 5000. dy, the second column, will be replaced by the matrix B. The remaining columns will remain as it is. Simplify it, you will get it as minus 8000. And finally, in dz, the third column should be replaced by matrix B, that is 8500, 38000 and 0, and simplify it, you are getting it as 8500. Now therefore, we can calculate the values of x. So x is equal to what? Dx divided by d, it is coming out to be 250. Y is dy divided by d, it is coming out to be 4000. Z is dz divided by d, it is coming out to be 4250. So x is 250, y is 4000 and z is 4250. These are the amounts which must be invested in three different accounts which are running at 2% rate of interest, 3% rate of interest and 6% rate of interest, right? Let us take this example also. This is an example which is somehow different rather than the questions we have solved. Solve the following system of equations using Cramer's rule. Here, 3 upon x minus 4 upon y plus 5 upon z is equals to 4. This is equation 1, right? It's very simple. 3 upon x minus 4 upon y plus 5 upon z, this is equals to 4. This is the equation which has given to us, right? Now look at this equation carefully. What kind of equation we have? We have an equation of the type of a1x plus b1y plus c1z, this is equals to d1, right? This is the standard form of the equation. So how you can transform this equation to this one? Think over it. Is it feasible for us to transform the given equation this to our standard form this? If yes, then how? Think for a moment, then I will explain. Is it feasible? Yes, of course it is feasible. How? See, if we take 1 upon x is equals to say a, 1 upon y is equals to say b, and 1 upon z is equals to say c, right? Now use this substitution in our equation. 1 upon x is taken as a, so it can be written as 3 into 1 upon x, so you will get it as 3a, right? Minus 4 upon y, this can be written as minus 4 into 1 upon y, you will get it minus 4b. 5 upon z, this can be written as 5 into 1 upon z, so you will get 5c. So what is your equation? 3a minus 4b plus 5c, this is equals to 4. This is our equation 1, right? So this equation 1 has been transformed to this, is it? Likewise, you can transform this equation and as well as this equation by using the same substitution, that is 1 upon x is equals to a, 1 upon x is equals to a, 1 upon y is equals to b, and 1 upon z is equals to c. So look at the solution, what we have taken. Let 1 upon x is equals to a, right? 1 upon y is equals to b and 1 upon z is equals to c. then the given system of equations transform, see 3a minus 4b plus 5c, and the second will be twice a plus 3b minus 5z. This is equation 1, this is equation 2, and the third is 13a minus 4b minus 7c is equals to 0. Are you getting this substitution? Now these three equations, they are already in standard form, right? a1x plus b1y plus c1z is equals to 0. Now we can find out its solution by using the same method what we are using for the last many exercises, right? But the difference is what here, the variables x, y and z, they are being replaced by a, b and c, and there is no difference other than this. In place of x, y, z, we are having a, b, c as new variables. So let us proceed. The above system of equations can be written in matrix form. Ax is equals to b. As usual, what is A? Now A is the matrix of the coefficients of the variables a, b and c. Be careful. A is the matrix of the coefficients of the variables a, b, c, because in this system of equations, the variables x, y and z, they are being replaced by a, b and c, right? These variables are being replaced by a, b and c. Now the system is written ax is equals to b, where a is this, x is this and b is this. A, you know, a here will represent the coefficients of the variables a, b, c in all these three equations. Let us take one. Coefficient of a is 3, coefficient of b is 4, coefficient of c is 5. So 3, 4, 3 minus 4 and 5. So this way you can write down this matrix A. X is here now a, b, c. In place of x, y and z, b will remain as it is, right? Now write down the determinant this. The value of the determinant this is coming out to be minus 154. Now this you will calculate yourself how this value is coming out to be minus 124. I have given many times how we can calculate the value of z. Now find out this is not equals to 0, and naturally if this is not equals to 0, it shows that the system of non-homogeneous equation will have a unique solution. Now find out dx and dy and dz. How we calculate dx, dy, dz, I have explained many times. The first column of the d should be replaced by the matrix B to get dx. The second column of the matrix, second column of the determinant D should be replaced by the matrix B to get dy. The third column of the determinant A or D should be replaced by matrix B to get value of z. So this is your dx, this is your dy, this is your dz, and finally this is minus 154, minus 154, minus 154. So fortunately they all are coming out minus 154. Therefore A is equals to 1, B is equals to 1, C is equals to 1, and what we assumed 1 upon x is equals to A. So 1 upon x is also equals to 1, y is equals to 1 and z is equals to 1. 1 upon x is v, 1 upon y is b and 1 upon z is c. So from here the values of x, y, z are also coming out to be 1, 1, 1 and 1. To solve the, let us take this case also. Solve the following system of equations using Cramer's rule. This is also almost the same question as we did in the last exercise. This is what? This is a system Ax is equals to b. Of course, this is a homogeneous system of linear equation, you know, and this homogeneous system of linear equation can be transformed. The above system of equations can be written as Ax is equals to b, where this is the matrix A, this is x and this is b, right? How we write A, I have already explained. Now this is the determinant of the matrix A. If you simplify it, the value of this determinant is coming out to be 0. And naturally, if the value of the determinant is coming out to be 0 and this is a non-homogeneous system, then it will either have no solution or it will have multiple or infinite many solutions. So for that we will find out dx is also coming out to be 0, and dy is also coming out to be 0, and dz is also coming out to be 0. So what is this condition? This condition is what? The determinant is 0 and dx is 0, dy is 0 and dz is 0. So this is the condition of what? The system is consistent. If this condition is satisfied, then the system is consistent and have infinite many solutions, right? So how we will find out infinite many solutions? Actually, infinite many solutions means what? Infinite many solutions means the values of x which we will obtain, they will contain constants. If I say x is equals to 5, what does it mean? It means the value of the variable x is 5. If I say x is equals to minus 10, it shows that the value of the variable x is minus 10. But if I write x is equals to c, c is any constant. If c is 5, x will be 5. If c is minus 10, x will be minus 10. So what does it mean? In this case, x depends on c. As c will change, x will also change, right? So by changing of c, c being a constant can have infinite many values. Therefore, x will also have infinite many values. This is the meaning of having infinite many values. So infinite many solutions means the values of x and y obtained from this system will contain a constant c. So how we will do it? We will do it, first thing, this is equation 1, 2x minus y plus z is equals to 4, x plus 3y plus 2z is equals to 12, 3x plus 2y plus 3z is equals to 16. What we will do? We will use C. Eliminate x from first and second equation. What we will do from equation 1 and equation 2? Eliminate x. You will get equation third, right? From eliminate x from first and second equation, and second and third equation, we will get these two equations. So what I am telling you, equation 1, 2, 3, we have given 3 equations. Solve equation 1 and 2 to eliminate x. Then solve equation 2 and 3 to eliminate x. So you will get equation 1 by eliminating x from equation 1 and equation 2, that is 7x plus 3y is 7y plus 3z is equals to 20. You will get equation 7y plus 3z is equals to 20. Then you will get solve equation number 2 and 3, right? From the first equation, if we take the value of z as c, right? If z is c, then the value of y will be this. Now z is c, the value of y is this. Now put this value of y in our original equation 1, that is 2x minus y plus z is equals to 4. So x is equals to this. Put the value of y. Finally x is coming out to be 24 minus 5c divided by 7. So what are the values of x, y, z? X is coming out to be 24 minus 5c divided by 7. Y is coming out to be 20 minus 3c divided by 7, and z we have taken as x. So this is x, this is y, and this is the value of z is equals to c. Now see, in all these solutions x, y, z, we are having a constant, that is c. So by changing the values of c, we will get a number of values of x, y, and z, and that is why in such cases we say that the problem is having infinite many solutions. Here I have taken k in place of c. It's your choice. You can take a constant c, k in place of c. So the solution is 24 minus 5k upon 7, it's a. 20 minus 3k upon 7, it's b. And k or c we have taken as z, right? So this is the solution of a problem which may have infinite many solutions. So try to understand the concept of this. What we did, these two equations are actually obtained by Solve first and second equation originally given. Eliminate x from equation 1 and equation 2. Then eliminate x from equation 2 and equation 3. So when you will eliminate x from equation 1 and equation 2, you will get equation 7y plus 3z is equals to 20. And when you will eliminate equation x from equation 2 and equation 3, you will get 7y plus 3z is equals to 20. Say 1 minute, twice x minus y plus twice x minus y plus z is equals to 4. Twice x minus y plus z is equals to 4. This is equation 1. And x plus 3y plus 2z is equals to 12. X plus 3y plus 2z is equals to 12. Wait a minute. X plus 3y plus 2z is equals to 12. 12. And third is 3x plus 2y plus 3z is equals to 16. 3x plus 2y plus 3z is equals to 16. So from these two equations, eliminate x. How you will eliminate x? Multiply this equation by 2. So what you will get? Multiply equation, this is 1, this is 2, and this is equation number 3. Multiply this by 2, you will get 2x plus 6y plus 4z, this is equals to 24. This is equation number 3. Now subtract equation 1 from equation 3. So see, twice x plus 6y plus 4z minus twice x plus y minus z is equals to what? 24 minus 4, that is 20. What is left here? Twice x and twice x will cancel out. 6y plus y, that is 7y. 4z minus z, that is plus 3z, this is equals to 20. So this is how you can find out this equation 7x plus 3y is equals to 20 by solving equation 1 and equation 2. Likewise, solve equation 2 and equation 3, right? To eliminate x, you will also get the same equation, right? Now in this equation, that is 7y plus 3z is equals to 20. If what we have taken, if we take x is equals to c, if x is c, then we get what is the value of y. Y is 20 minus 3c upon x. By putting this value x is c, now putting x in y in 2x minus y, this is equation number 1. If we will put the value of x and y in this, we will get x as this. So x is coming out to be simply 24 minus 5c upon 7, y is coming out to be 20 minus 3c upon 7, and z is coming out to be c. In place of a constant c, you can also take a constant k, as I have taken here this as a solution, and this is a problem having infinite many solutions. It's all about the content, students. So thank you very much for your patience learning.